Thanks for tuning in to Stay Sharp with Razorleaf, your secret weapon for all things digital and products and manufacturing. When people use the acronym PLM, many are referring to the technology, but others may be referring to the business process of PLM, which can reach much beyond the scope of the technology. We invited a special guest, Patrick Hillberg, to join our podcast team to discuss the challenges of managing a product's lifecycle beyond traditional PLM thinking. They explore many concepts, including the impact of externalities around product development, particularly in relation to the supply chain disruptions. They also discuss digital twins of factories and the potential for remote manufacturing. Ultimately, Patrick notes that people need to understand the importance of the job to be done and explore alternative approaches to achieve it. Let's tune in.
Welcome back, everybody, to Stay Sharp, the podcast about all things digital related to products and manufacturing. I am Jen Farrell, and I'm joined today by my colleague, Jonathan Scott.
Hi, everybody.
And in a recent podcast, we had begun talking about the aspects of managing a product's lifecycle beyond the capabilities of current PLM systems. But if anybody's listened to that, and if you haven't listened to that conversation, you really should, because this is a continuation of that one. We barely scratched the surface, and I had to stop kind of at the end to make sure that we stayed on time. So we invited our guest, Pat Hillberg, back to continue the conversation. Patrick, as you may recall, after spending decades designing, developing, and leading teams in PLM, digitalization, and advanced manufacturing, is now a speaker, author, and professor. I highly recommend, by the way, checking out his website, patrickhillberg.com. And his real passion, his driving passion, is the need to develop a workforce for the fourth industrial revolution. And some of the driving forces behind that need to overlap with the reasons that you need, or actually overlap with the reasons that you need to go beyond traditional PLM systems to manage your product's lifecycle. So welcome again, Patrick. Glad to have you back.
Oh, thank you so much for having me back. I always enjoy speaking opportunities, and it's great talking to you guys. And let's make sure that we do circle back on the workforce aspect of things, because
or it'll be the third podcast we do with you. It's fine.
Podcast, right. So.
No, it's always good conversation, and as you mentioned, Jen, this is sort of picking up where we were talking before, because I think we got lots of good things to keep talking about. I'll maybe try and connect back a little bit, right? So in that last conversation, we talked about PLM and PLM systems, right? And I talked a bit about how I try to differentiate those, because a lot of folks think of them as one and the same. And it's like, no, the activity is different from the technology and the system, that kind of thing. And that's where Patrick added in, his concept about managing product lifecycles being an activity and a thing that you do, and it's not covered by PLM tech fully, right? And in the conversation, that got us into something, which is where I want to kick us off today, right? Is you asked the question, Jen. So where are those gaps, right? We talked about one early in the product's lifecycle about deciding what product to make. What are you trying to do to serve the market? Who are the stakeholders you're trying to address? That kind of thing. And there's some pieces of PLM tech that loosely help with that, with requirements, but it doesn't really make those big decisions. But you challenged us and said, what else, right? And I thought of one, right? So here's one that I think that PLM tech, again, touches, but doesn't really address. And that is the broader picture of all the components that go into your product and how you get them on time to deliver on time, that sort of thing. And the reason I bring this up is it was highlighted because of the pandemic, when we had supply chain shortages. And what it made a lot of companies realize that they're still working on today, and I imagine some PLM tech providers are also working on today, is how, when I'm designing the product, do I consider whether I can get the parts or not? Or if I can't get these parts, what are those parts that could do the job instead? And how can I still get the product out the door and yet still maintain my cost, quality, schedule, balance, and all those things? That piece of product development, yeah, there's some PLM tech that can help, but do we have solutions for that? Is that part of what PLM tools do today? And I would argue, no. So that's I wanted to bring that example back and see, what you guys thought of that. Like, does that fit what we're talking about? You need to manage that as part of your product lifecycle, but we don't always have the tools.
So it totally does. Matter of fact, I'm going to I've watched some of Pat's lectures online, and one of the things that he talks about in that is basically, we had talked a little bit in our last podcast about how the concept of product is expanding. It's going from it's not just mechanical anymore. It's mechanical and electrical. It's mechanical, electrical, and software. And it's going out into different environments. We touched on autonomous vehicles. So the definition of product is changing, but also in that change, what we're starting to actually take a look at also, and Patrick mentions this in some of his lectures, is the externalities, positive and negative, that affect and are caused by some of the product development that we do. And matter of fact, so one of the externalities was the pandemic, which is which changed the supply chain dramatically and had to change the way we were doing processes. So, Patrick, I wonder if you could go and talk a little bit about what you mean by externalities and what some of those are.
Sure. So, and again, I cover this in the section in class. So if you look at, we do one section on capitalism and externalities combined out of a terrific online textbook that was developed by Oxford University. And we go through the Adam Smith capitalism, which is, so the three tenets of capitalism per Adam Smith are private property, markets, and firms. So the idea that you can privately own something, you can buy that thing that you privately own at a market. And the firm aspect gets into, it's not just a family business where you keep the weird nephew online because he's, your wife's going to get mad at you otherwise. So, so that's the role of a firm. Externalities are people who are impacted by the product, the use of the product, who are not part of the market contract. So the example I fall back on this, the first example I fall back on this, unfortunately, they're not going right now as I'm recording, but my neighbors have lawn mowing companies that will mow their lawns, and they'll use these big noisy leaf blowers. And I needed, in desperation, to eventually purchase noise canceling headphones for when my neighbors are using their leaf blowers, right? So there's a market contract between my neighbor and the leaf blower, and I'm negatively impacted by that. But I'm not part of the market contract, and they're not having to pay me for the negative aspect on my quality of life. I should say there's also positive externalities, and positive externalities is reinforcing growth, which is the network effect. So, 100 people joined Facebook, and it wasn't that big a deal. But when they each brought in 5 of their friends, and those 5 friends each brought in 10 of their friends, and now suddenly Facebook has 3 billion users or something of that. Somewhere in the line. So that's a positive externality in that each person who's already a member of Facebook perceives more value out of Facebook as new members come on. So right. by growing, bringing new members in helps. The supply chain thing. So there's a terrific book written in 2014. I read it during COVID. I'm sorry, it's The Butterfly Defect by Ian Golden and Mike Maria Faison. And they refer back to a study.
What a great title, by the way.
Yeah, right? Yeah. So it's a terrific book on systemic risk. And it's about 10 chapters or so. And they go through a variety of systemic risks that can occur, one of which is supply chain, one of which is pandemics. And those two things, per Jonathan's comment earlier, definitely overlapped in 2020.
Right.
This was written in 2014?
Yeah, in 2014.
Huh, interesting. And you were reading it during the pandemic.
Yeah, well, we were all stuck at home, right? I might as well read something.
Right, I know, but it's just ironic that you were reading something written 6 years before that was playing out, basically.
Let me go a little further on that one. In that book,
okay, you do that.
There was an epidemiological study done in 2005 when SARS-1 first hit, and they realized that one infected person who took 3 trips of international travel would infect enough of the world that the entire world would need to be vaccinated,
Wow.
which happened 15 years later.
Right.
Right. So, and I bring this up on, I won't go too deep down to this, but how do you want to, truly in my opening lecture in class, I ask, if you were the CEO of an airline or a hotel, or look at what's happening in commercial real estate now, right?
Right.
And you read that book in 2014, and you realize that that book was exactly right. This pandemic that was predicted there, you knew what was going to happen. What would you do? And I don't know that we've got the mechanisms to deal with that. How do you go to your shareholders and say we've got to get out of? Okay, I'm not gonna go too far down that line, but
yeah, what do you do? It's a tough question, right? I mean,
yeah.
what do you do about low probability risk, but high impact risk, and particularly when you can't predict, because it is low probability, you can't predict when it's going to happen, right? I mean, it's fair to say.
You know what I would answer? That's what lawyers are for. Honestly, I mean, I'm not wrong. That's why contracts exist, right? Any partnership contract, you write it and it spells out exactly what's supposed to happen. And then you put it in a drawer and you hope none of that should ever happens. Right. You never actually have to look at that again. So
let me go back to the supply chain thing.
Yes.
So in 2020, COVID hit. I was in the midst of teaching in the middle of the semester, and oh my God, was that a panic? Trying to figure out, this class that I normally teach in person, and suddenly, actually, on that particular case, I looked one night and said, okay, all of the East Coast colleges were closed, all the West Coast colleges were closed, all the colleges in Ohio were closed. There's just no freaking way that we're going to last for the rest of the semester, right? So I told class on Monday night that in fact, Zoom didn't even exist. So we're going to do the whole thing on WebEx tomorrow.
Right.
And that was a panic. So by the following year, I completely restructured my course. I mean, reading that book, I wrote an article for an academic journal, which got me doing a lot of studying, and I just completely changed the class, how I teach the class. Back to supply chains, something I've always wanted to teach, and it just really became easier once it was online, is Harvard Business School makes available a simulation called the beer game. And actually, MIT developed this beer game supply chain simulation in the 1960s. And what's really cool for my purposes is that for $15 a student, they can run the simulation online, which just makes it an easier thing to run. There's a four stage supply chain. There's retailer, distributor, wholesaler, and factory, and incoming demand from customers is very stable quantity. And after a few weeks, suddenly customer demand doubles. So what happens to the supply chain when customer demand doubles, particularly since the retailer can't talk directly to the wholesaler? They can only issue orders to the wholesaler. And the wholesaler can issue orders to the distributor, and the distributor can issue orders to the factory. And what ends up happening is that this perturbation in demand suddenly ramps its way through, and by the different teams work different ways, but in the roughly 40 weeks that the simulation goes on, customers demand 4 million cases of beer, but the inventory at the end is usually 8 to 10 times that. So there's right. So
whoops.
35 to 40 million cases of beer in the system. And I recorded this lecture again for my students, and there were, I think it was 18 months of inventory. For the one student team that I followed who was right in the middle, there was 18 months of inventory at the end. So the factory, because of this small perturbation, I mean, it's a doubling in demand, right? So that's not small, but because of this perturbation, you end up in a situation after 40 weeks where the factory can shut down for the next 18 months because there's so much inventory built up into the system. So So this is some of the supply chain things that go on. And you say, oh, okay, this would never really happen in real life. But then you look, one of the examples I give is Peloton bikes, and huge demand for Peloton bikes during the pandemic. And then the demand probably really just leveled off, but inventory got overwhelmed, et cetera. Anyway, I won't go too far down that line, except that my students are all in the auto industry. We go through this thing in February 2021. It's abstract theory coming from weird Professor Hillberg at this point. By the end of the month, all of their factories were shutting down because they didn't have integrated circuits. It was exactly the beer game. And what had happened in this case is when autos thought that everything was going to collapse, so they pulled back a lot of their orders on the IC manufacturers. The IC manufacturers started building things like Apple, like whatever is needed for Zoom and all the cameras that we now have in our offices and that sort of thing, right? So in any event, so there's this supply chain dysfunction. So you have this externality, which is the likelihood of a pandemic, and we have a highly distributed supply chain, which is very susceptible to the issues that we all saw during the pandemic. And even on a really simple supply chain of only four stages that my students run, you can see the dysfunction happening.
Right. And that's one where you can sort of understand, right? You can understand the supply chain because it's been simulated to be something that's manageable. And, today's supply chains, they're often so complex, we can't really understand them exactly what's going on, right? And, I want to just make a quick sidebar here. I mean, there's a whole sort of area of IT, supply chain management systems that do focus on this. I don't mean to cut that short or give that not the attention it deserves. But, what I was bringing up when I connected these dots is, but is it tied into product development the way that it should be or needs to be or whatever it is? When we think about managing the product lifecycle, do we have the understanding we need to have to support the activity we're trying to do? And that's where I think we don't have the tech or the connections or something. And I don't know if we're even working on it today. Is it seen as, well, it happened during the pandemic, but it'll be a while before I have another one of those. So
hopefully not. I mean, hopefully it will be, but hopefully it at least brought it to our attention so that we can be preparing for, if not that, then some other disruption of our supply chain. So for instance, with climate change, there are a lot more storms, a lot more catastrophic events that might knock countries, regions, et cetera, offline. Well, if that's where you get all of your X, Y, and Z components, that is right. Another thing that's going to impact your supply chain.
Or a geopolitical conflict, for example.
Yes, geopolitical conflict.
Yeah, I mean, all sorts of things. And this is, I think, and I'm going to connect this back, and maybe I'm doing it falsely, and you guys are going to tell me I'm crazy, but I'm going to connect it back to the premise of, why we had Pat on for this first episode and why we're continuing it here is managing product life cycles is about thinking of these other things that are not necessarily what the technology in the PLM space gives us today. It's about zooming out and saying, wait a minute, what really matters in getting our value delivered to stakeholders, right? What is the value we're delivering? Who are our stakeholders? What does that look like? And saying, all right, now PLM technology, maybe it covers this much, but here are the other things we do or need to do to deliver that value. What are we missing? What are we forgetting to pay attention to? What's going to happen to us if we don't think about it ahead of time? I mean, is that where you're taking this, Pat?
Yeah, most definitely. And I'll tell you, and this kind of wraps back into the workforce deal that we talked about earlier.
Right.
I think we need to shorten supply chains. And I'll just jump to the end. Actually, if you think about, one of the failure modes in climate change is sea level rise. Now, all of our banks built around the port. If you go back, 400 or 500 years, you put the bank right next to the port. So all of our financial centers are within just a couple meters of sea level. If you look at New York and London and Vancouver and some, anyway, all. So there's a tight connection between our banking system and being close to sea level. So as sea levels rise, the regions that are likely to get hit are the same regions that are already running our banks now. What I get to on this is I mean, my overwhelming goal is we need to figure out how to bring value to society. And that's the one argument I really don't take in class, right? And nobody ever argues that one. So, how do we bring value? How do we bring value to society when we have these systemic risks and climate change? So, COVID certainly showed that we have a systemic risk. The book I mentioned, The Butterfly Effect, shows a number of other systemic risks, and climate change is this very present systemic risk. We have an economic system. So when we think about managing product life cycles, our product life cycles are built on the idea of where can we find inexpensive components, and we can find those inexpensive components from overseas. So what starts to happen is you have localized regions that become very expert at certain things. And then we ship what they can produce out to other places. So actually, I need slides for this, but
That's right. We all think in PowerPoint.
Yeah, right, yeah. So right. So there's this point where a company wants to expand, and they have a factory in a certain location, and they say, okay, we think we can sell these products or components of some larger product in another location. Should I expand my factory in the current location, or should I build a factory in the other location? The reason I would want to expand my factory in the current location is because I have the local expertise in knowing how to run that factory, how to build that part. So I can build that locally. And if you think back, so I live in Detroit, if you think back to what Henry Ford did in the 1920s, 30s, 40s, 50s, there's a lot of expertise in how to build an automobile that was centralized in Detroit. So it made sense at that point to build cars in Detroit and then ship the cars worldwide rather than distribute that out.
So just to track that real quick,
Sure.
the idea there is efficiency, right? My workforce already knows how to do it. I can do it more efficiently here. And when I compare that to the cost of shipping it, well, it would be harder to get the workforce there and the factory there and all that stuff than it is just to ship it. And so that's the cost benefit that happens that says, build it here.
Right. And thank you, because that is exactly the dynamic. That's exactly the tension of which is seemingly more cost effective to increase my local workforce and ship the products globally, or do I globalize my workforce and make the products locally? And climate change is a big problem. I don't see this is going away. And I think if we want to bring localized value to society worldwide, we need to localize manufacture. And what I'm going towards is 90% of what you consume should be manufactured within 1,000 kilometers of your house, of where you consume it. There's some stuff that just won't work, but we need to minimize the amount of transport that we do. And this, to me, then gets into unrecognized value on digital twins, where we can create digital twins of our factories. So not just thinking about digital twins of our products, but thinking about digital twins of our factories and remote those factories out around the world. And the example I used in the speech that I know you guys were at the PDT that I gave a year ago was in RNA vaccines, and which I'd never heard of before.
Nobody had
COVID, but
nobody had.
The RNA vaccines actually the factories are immensely easy to build, according to a research study that I read at the time. So the factories are immensely easy to build. And the idea of building 1,000 RNA vaccine factories around in 1,000 different locations around the world. So now you can deliver these life-saving vaccines. And it's not, the vaccines were developed pre-COVID, and they think there's a lot of value in cancer, helping people through cancer. So there's a ton of value in remoting those factories around. But if there's 1,000 factories in all sorts of locations around the world, we need to communicate between the different factories. We need to collaborate between the different factories. I'm really big on the concept of collective learning. We need to collectively learn amongst the different factories around the world so that they can get the most vaccine out. I mean, at this point now you're talking efficiency, get the most vaccine into the most shoulders as possible, local to where they're produced. The RNA vaccine needed to be kept at like 70 below centigrade.
Right.
Yeah.
Super cold.
It was in 2020, it was only manufactured in 12 locations around the world, one of which was in Kalamazoo, which is not too far from where I am. So to ship the vaccine around the world, you weren't shipping vaccine, you were shipping dry ice.
Right.
Right. So
yeah, this much vaccine and this much dry ice. Yeah.
Right. Exactly. I mean, for every ounce of vaccine, there's probably 4 pounds of dry ice. I don't know what the number is, but right. So if we can localize manufacturing, but so I think in terms of managing product, so what's the job to be done by a vaccine? Well, it's to inoculate people from disease, and how do we do it? Okay, so the current. I'm sorry, I'm wandering a bit, but 3 tenets to innovation.
I was going to say before you go on to that, Patrick, I want to connect what you're saying about the vaccines back to something very, very tangible, I think, to our audience. When you talk about localized manufacturing, right? Hopefully, lots of light bulbs are going off for folks going, yeah, this is the topic of additive manufacturing. Everybody's like, oh, yeah. Well, if I could just put my 3D printers in my factory here, I could put a factory everywhere. And right. But I think they are very connected to your point about digital twin of a factory. That's where we're still not there. We're still working there. And this world of additive manufacturing is expanding and growing. And we're getting all sorts of new capabilities every day from the people who are innovating in that space. But sure, if we get there and we can make metal and plastic and rubber and this and that and start to make all these things, and we've got robots to help us assemble and what is the missing piece? Well, the part we've got to be building out in parallel is that digital twin capability, right? The ability to plan all of the right additive machines and assembly machines and everything to put together the product you want to make locally and protect it. That's another thing I wanted to mention as you were talking about this idea of distributing the workforce. One of the big issues I hear lots of people talk about is, sure, but if I could make it anywhere, then anybody could make it. So you have to protect the intellectual property while you do it. But anyway, I really like the example that you're bringing up, the thing we should be thinking about. I just want to make sure the audience is connecting that to vaccines and hearing like, yeah, this is all kinds of products, not just a vaccine.
Right. Yeah. To your point, it's not just vaccines. It's basically every product. I mean, I can recall a few products that were running completely low during COVID. Like toilet paper was like gold. Yeah. Very small, like pathetic example, but it's true.
But don't you wish you could make it locally? Right. Yeah.
Right.
Yeah. So to kind of recap, as the global economy expanded after World War II, factories we started localizing efficiency regionally. So we start building regional efficiencies on how to manufacture things and then start shipping those things around the world because shipping was less expensive. Really, shipping was less expensive than building up the capabilities to manufacture worldwide.
Right.
But what we saw in COVID and what I think we're seeing, we're just going to continue to get worse and worse as far as climate change. The ability to ship components worldwide is highly risky. There's a lot of risk in it. As I'm talking about this, actually, the Canadian trains are on strike. So the auto industry is currently concerned that they're not going to be able to get the parts, and especially when you look at something like automobiles, where each plant is building 1,000 vehicles a day, and each vehicle has 20,000 parts in it. Any one of those parts doesn't show up. They can't use anything, right? So, I mean, there's a little bit of fuzziness there. I had a student in 2022 who said he was tramping through farm fields where they had parked the vehicles that weren't completely built yet because they didn't have the IC circuits, but there were good IC circuits that could go into other vehicles. So he was walking through farm fields in Indiana, pulling chips out of existing vehicles to send the chips back to the new vehicles so that they could build the new vehicles. And I said, okay, what part of your engineering degree prepared you for that? So,
but that ties us right back to what brought this up, though, Pat. Right, which is that idea of where is tech maybe not filling all the gaps we have today. That analysis, right? I can't think of a system that does that. That says, hey, play a game, play a simulation on this one component. If this one gets scarce, tell me out of all these products and all my manufacturing plans and all my plants and everything, how do I maximize profit right now? Right? Which cars do I put the chip in that I can ship instead of, oh yeah, we just kept things running, put them all in a field, and later we had to go back and pull chips to ship cars, right? Where's that? And that's the part of managing the product lifecycle, that if we don't think about these things, we won't create the tech to support the decisions to give us what we need.
Right. Yes. But I think when it comes to managing product lifecycle, there were many articles that were written, particularly in 2020, 2021, as the supply chains were going bad, about this, that there's very little visibility down the supply chain. The OEMs tend to tell the tier ones, okay, this is what we expect from you, but whether or not that's actually making its way further down is not happening. And there's a good article on this in the HBR that the Harvard Business Review talked about it, that they talked to a tier 3 or something. He says, yeah, we would love to do all this stuff that we're supposed to do, but you also come back and tell us that we have to ship this amount of product in this amount of time, and we just don't have the ability to do both of those things. So there is some stuff. I mean, I know I've done some stuff in PLM systems where the example was we can't get a 2-cent resistor because of the Fukushima
nuclear disaster.
Yeah, the tsunami. But right.
Right.
So there was a tsunami in Japan, and we can't get 2% resistors. We can't get 5% resistors, but we can get 2% resistors that cost 3 times as much, but at least we can put out the rest of the product at that point. So, but in terms of really understanding the supply chain, everything I read says that there's not good information on that. So there's a lot of interest in it. People recognize the issue. But
so let me ask a question, and I know we're probably coming to the end of our time.
We're getting close. We're getting close. But we have the ability to ask Patrick back, so it's good.
That's good. That's good, because there's lots to talk about. But let me ask one to maybe to close this topic. So with that perspective, with what we see about PLM tech covering a certain piece of what managing the product lifecycle should look like, what's your view on what people should be doing? Right? Is it you need to take the existing tech and just look at how to expand it into what you need? Oh, you need to look outside of that tech to the other tech maybe that already exists and how you might reuse it or repurpose it. Like our supply chain point, right? I bring up SCM systems are around, they exist. PLM systems are around and they exist. Have you connected them in a way and extended them to suit this need? Or is it, focus on your requirements first. Take a step back, look at it as a business or an organizational problem, and then do your research. You might have to write tech. You might have to reuse or repurpose tech, whatever, but think about what you need. What's your advice to people, I guess, is my short version of my long-winded question. Sorry, Pat.
So in the previous podcast, I think I talked about how my students who mostly work in the auto industry were choosing Zoom over driving to campus. And that's a simpler means of getting the job to be done, or of accomplishing the job to be done. So 3 tenets to innovation, I think I mentioned it. What's the job to be done? What assumptions must hold true in order to accomplish that job? And what are the alternative approaches? And I'm going to come back to the alternative approaches at this point. We need less complex means of doing the same job that we're currently doing. And again, I always fall back on auto industry, but there's a lot of stuff that could be done without cars if there weren't so many cars. Cargo bikes, for example. I live in a town that's 5 square miles, and there's a grocery store that I like, which is 2 miles from me, and I bike 100 miles a week, but I don't bike to that store because there's not an easy way to get there without having to deal with a lot of cars. And I talked, I think, in the previous podcast about autonomous vehicles. And so we're adding more and more complexity to these things where there's actually very there's much more simple means by which we can accomplish the job to be done. So what are the assumptions that need to hold true in terms of autonomous vehicles? Well, the thing needs to work. There's all sorts of technical things that eventually says it needs to work massively better than a human driver. But I look at train systems in other parts of the world, and they're incredibly fast and incredibly safe, and it's already there. So there's a simpler means of doing what is currently what's being attempted with autonomous vehicles. So,
right, to your point about cargo bikes, right? I mean, I love visiting. I love visiting Amsterdam, and
Yes.
that's one of the things I'm very impressed by. Right, is I see the bike culture. That's one thing. All the infrastructure. So you're right. There are a lot of things you need to think about. But when I see tradespeople on a bike with all of their tools, materials, et cetera, and I'm like, boy, that's just a different way of solving the problem. That's fascinating.
I used to fly to Augsburg, Germany, every 8 weeks, and I never was in a car the entire time I was there. The plane would drop us in Frankfurt, and then a train would take us 1 block from my hotel. There were local trains that was 1 block in the other direction that would drop me off right in front of my clients' offices. You go into the client campus, and there are hundreds of bikes around because that's how people commute onto campus. And this was a robotics company that was building assembly lines for automobiles.
Wow.
I love
Talk
it.
about ironic.
So yeah, in my own town, I look at stuff. It's like, there's one main drag that runs east and west. If that main drag was closed to vehicles for 15 minutes an hour, such that people knew that they could get from one side of town to the grocery store, do their grocery shopping, and 45 minutes later get back home on their cargo bike, there's a much simpler means of accomplishing the job to be done than what is currently going on. So I think that's my thing is we need to go back to how we, what is it that we're truly trying to accomplish, and are we just adding technology onto a overwhelmed system to try not to be overwhelmed, or do we need to go back to cargo bikes?
So it makes me think what you're getting at is we need to measure the cost of complexity.
Yes.
Interesting.
Yes.
Well, and not just that. What I'm hearing both of you say is that we need basically. So if I can recap, products. The concept of a product has expanded. It's not just what you're delivering; it's the effect that it has. All pieces of it have on not just actually. So your product is expanding. Your stakeholders are expanding. It's now not just your customers, it's the people around them. It's you and your neighbor on the leaf blower. But it's also, and it's society is now a stakeholder because of climate change, global warming, et cetera. So your product's expanding, your stakeholders are expanding. The complexity of the products that we're producing are expanding. And we have a whole lot more externalities because we're a global economy that are affecting all of this. And the challenge is, we need to perhaps take a step back and engineer out some of that complexity so that we can respond more quickly, more locally, et cetera. But how to do that in a way that is profitable, and not just profitable because we all like money, but profitable because that allows us to continue to do those things.
Right.
And to provide value.
Yeah.
So I think that we're going to have Patrick back. We're
Sure,
clearly not
I'm
going to solve
happy.
this today.
There's that curse, right? May you live in interesting times, and these are very interesting times.
They
Yeah,
are.
yeah.
They are.
Well,
and exciting,
I was going to say, and if the goal is for the three of us to solve the world's problems, that's a lot of having Patrick back. But boy, it
the
is
world's in
interesting.
trouble.
It is
It's up to us.
fun, though. It is fun, though, isn't it? And
Yeah.
this is a very fun discussion. So
Cool.
I'm
Cool.
I'm hoping that all the listeners out there, maybe we'll give them a little bit of time in between this and the next episode, because I'd really love for folks to weigh in on. These are very thought-provoking things that we have said today, both the expansion as well as the complexity, and the thought that maybe we need to take a step back and reimagine what things look like, or what the solutions are. So maybe autonomous vehicles is not where we should be spending all of our time. Maybe it's simpler solutions. But again, there's a cost and risk trade-off there. So anyway, for our listeners, please reach out, comment on this episode, other episodes, ask any questions you have, be part of the conversation because this is your changing world too. So, Jonathan, thank you very much for joining me as always.
Fun as always.
Pat, these two podcasts that we've done, I think, are some of the most fun, at least for me, and informative for sure. So thank you for joining us.
Yeah, and glad you could be here, Pat.
Yeah, and to all of our listeners, until next time, stay sharp.
Thanks, everybody.
Thank you for being here and listening to this episode of Stay Sharp with Razorleaf. If you have any questions about this episode, we'd love to have that conversation. Just leave us a comment on our post or send an email to podcast@razorleaf.com. If you like this podcast, please be sure to hit the like button and subscribe to our podcast on your favorite platform or on our YouTube channel. Until next time, stay sharp.